All right. Oh, Father, thank you. We're about to start. So you need to start from types of control charts. So we have two type of control charts, an attribute control chart. Now, variable control charts. These are the average, which is the X bar, the R, and the standard deviation. Then for the fraction defect, which is the P. Then the chart for defect, which is C. Then chart of number of defect, which is D or MP. So now, before then, we should try to know what is specification, tolerance limits, and comparison between attribute charts and variable charts. So I'll just read through them very fast before we treat those examples there. Okay. The types of control charts. Let's start from the specification. Specification is the maximum and the minimum limits of variable of individual item. As mentioned in the limit is the difference between the high limit and low limit, which margins allow for variation. It is the allowable limit a product is said to go far from accuracy or perfection without. Then the next is the comparison between attribute charts and variable charts. So one of the comparison is that talking about the X bar, the R, and the standard deviation, while the attribute charts talking about A, the MP, the C, and the U. So now the variable chart now, a measured value of characteristics, while control proportion of defective or number of defective. The next one is provide maximum utility of information available from data. Data is special recorded. They are not easily understood unless training is provided. They do not provide that. So now we're going to treat an example on how to find a defect. So now we're going to look at question. We're going to look at problem 1. Now we say problem 1. The control chart for X bar and R part. Oh, sorry. This for you. I give you 2. Okay. Yeah. Says Following magnet for 19 observation. So here we are giving 19 observation. Number of magnet inspections. You can see this how they queue up the number of magnet inspections. The next column is talking about number of defect magnet. The last one is talking about fraction defect. So the problem of P. When anytime you hear about fraction defect, this is the problem of P. So first thing, P, and your formula for P is P equals to P bar plus of PQ all over N. Now, where most of us are having is our N by Q, same as 1 minus P bar. It's actually gotten from the number of magnet inspection, the total number of weak numbers, which is 19, average sample size, which is our N. So the average sample size is the N, which is this N. To find the average fraction defect, and the average fraction defect is always number of magnet inspections. When you do that, it gives you your P bar. So, having gotten your P bar, the next thing is to find answers. So if you look here, the upper control limit P is equal to this. So we know our P was gotten from then we have for P bar plus 3 into the root of P bar by our small n. So if you do that, the answer. Therefore, the lower control limit minus 3 the root of all divided by n. So when you after getting it, you draw your conclusion. We conclude that from sample number second and fourth are going above the upper control limit and control limit. Therefore, the process does not exhibit statistical consequences. What they said here, just for you to understand it. Second position and third position. So when we look at the, we know that if we check this, our upper control limit is 0 and lower control limit is 0.044. So if this should pass, if any number should go below this, it is out of control. If any number should go above this, so do we understand? So if you can check now, from your fraction, see? Now here we have, it's not higher than this. Now we check number 2, we have 0.109. So you can see 0.109 It's higher than our upper control limit. So that is our first defect. If we check the position 4, we have 114, which is higher than what we have here. So in that case, this is our second defect. It's higher than. If you keep comparing, you discover number 19, 0. Lower than 0.0444. So this is lower. So this is one of our defect. So because you draw your conclusion saying that what? You conclude that from the resulting control chart, sample second position and third and fourth are above the upper control limit and control limit. Therefore, the process does not exhibit statistical control. Then problem two says a certain as it is manufactured and the resultant data are summarized by the hour. In the following table, data are recorded. Calculate the control limit using 3 sigma control limit and indicate the values that are out of control. Now in this case, 16, right? 16 hours. There are a number of our n. We're always going to divide a number of units inspected by the total number of hours. So we'll do that to get our small n. Then for it's very simple. Just for us to scatter the whole paper. All right, here. So it's going to be this is our n. So when you do that, using the same formula, so limit and lower control limit to make sure that above or below it. So here we have minus. So if you can check position 0.15647. So this implies that has gone beyond the upper control limit. Exhibit statistical control. So problem 3. On bullet bolt in carton that usually contain, and each shipment consists of number of carton as a part of the acceptance procedure for the bottle. 400 bolts are selected at random from each carton and subjected to a visual inspection for certain defect in a shipment of 10 cartons. So the respective percentage of defect in the sample from each carton are this 0, 0, 0.5, 0.7, 0. 0, 2.0, 2.50, and 0.25, 1.25. So what we do here is, it said we should, does the shipment of the boat appears to exhibit statistical control with respect to the quality characteristics examined in the inspection. So first thing, we look for our n, our small n, which is the average fraction defect. And the average fraction defect is always what the total number of defects over total, sorry, this is p bar. Our p bar is total number of defects divided by total number of inspected defects, inspected unit. So when you do that, the inspected unit we're given in percentage. So these are the percentages. So for us to convert this from percentage, you have to divide it by 100. So we have this times 400 divided by 100, then divided by 400 times 10. So 10 is the number of the carton because there are 10 units here. So when you do that, you have 0.005. So I haven't done this. The next thing I want us to look at is that still remains the same. So in this case, our n is 400. A part of the acceptance procedure for the boat, 400 boats. That means 400 boats are selected at random. So that's why our n is 400. So we've gotten our n is 400, is 0.05. So with that, we are clear. Just to input it in the formula, you go back and compare your result and see if it's in statistical control or it's not in statistical control. So if anyone should go above that you gotten, then it is out of what statistical control. Yes. So this all unit 2. The next thing we are going to be looking at is how to compare P chart So when we look here, how do you compare P chart and X bar and R chart? The purpose of the P chart are meant for. Then you should know the difference. Then the next one is classification of defects. It has minor defects, major defects, and for minor defect, major defect, and critical defect. Then the next, sampling inspection. So sampling inspection Oh, sorry, I didn't know it wasn't clear. Is it clear now? Because it wants to ring here, that's why it's not clear. Okay, it is better. In case it's not clear, advantage of sampling inspection. You also check the limitation of sampling inspection. sources of sampling inspection, uh, consumers risk, the definition for AOQ, then types of OC curve. I think we have two types of OC curve. So that's where let's go live on WhatsApp. Let's see if I can help in that aspect. Thank you.